Okay guys, this is my third take of this video, so it better be amazing this time or I give up. But hopefully I've learned a lot. So first thing you need to know is this complexity of a problem will not likely be on your GED. You will see quadratic equations on your GED, don't get me wrong, but this is an extremely complex type of quadratic problem that involves you solving it backwards. It's like doing the opposite of solving. You might have to solve them on the GED, but you probably wouldn't have to do this skill. That being said, I am still going to do it because A, somebody asked for it, and you know I can't stand to not answer people's questions if you know me. And secondly, it does come up in your college algebra classes, so you need to know how to do this for college algebra. Okay, so that being said, I have one more warning for you, and that is that there are prerequisites skills. In order to understand this video, you must thoroughly understand the following three concepts. One, you must know how to multiply binomials. If you do not know how to do that, you will find this video way more confusing than it needs to be. There is nothing that is that difficult in math. However, if you try to do too much at once, you will find yourself overwhelmed and think math is much more complicated than it is. So you must know how to multiply binomials. Hopefully you also know how to spell, unlike me. Okay. Second skill that you must know how to do is you must know how to factor trinomials. If you do not know what I'm talking about, you might want to Google it, check it out, check out a YouTube video and see that. The third thing you must have experience with is solving quadratic equations by factoring. If you do not know how to do that, again, you are going to be super duper lost. Okay, so those are your three prerequisite skills. Make sure that you know how to do those before you ever attempt this video or you will find yourself overwhelmed. That being said, let's begin. Okay, I'm going to read this question. What is the quadratic equation whose roots are -3 and -1 and has a leading coefficient of 2 with x to represent the variable? Okay, let's break this down. There's three terms in here that you have to understand in order to be able to solve this. The first one is, what is the quadratic equation? Quadratic equation. You have got to know that a quadratic equation is anything that can be written in the form ax squared. So it has some number of squares, some number of x squareds, I should say, plus bx, so we have a plain old x term, plus c, we have a constant term, a regular old number, equals 0. So the a, the b, and the c would just be numbers, but you have some number of x squareds, some number of regular x's, and then a constant. And if you can write it in this form, it is a quadratic equation. Okay. Other thing you need to understand is roots. A root of a quadratic equation is another name for its solutions, the things that x could be and make it true. So a root is a solution. So basically they just told me the answers to the quadratic equation. They said if you solve it, you would get that x is -3, that x is -1, my solutions. And last thing they tell me is the leading coefficient is 2. You need to understand that the leading coefficient is the number that's hanging out with the highest exponent term, the leading term here. The leading term has the highest exponent, the highest index. I'm saying the same thing different ways, but whichever one of these x's would have the highest exponent is the leading coefficient. In the case of a quadratic, this is a quadratic, the leading coefficient is always the number that's with x. So our a here would be our leading coefficient. Okay, now that we understand all this language, let's go ahead and get started. And I'm going to have you remember this last thing that I had on this list, this prerequisite skill of solving quadratic equations by factoring. Basically, this thing is asking you to move backwards, to start with the answer and move back to the quadratic equation. So in order to do that, let's look at the steps that we took when we started with the quadratic equation and solved for the answers. So different ways to solve quadratic equations, but this particular thing we're looking at is the opposite of solving it by factoring. So you need to understand this particular concept, solving quadratic equations by factoring. So I will just really quickly remind you, again, this is not a um, full explanation of this concept, you should go look this up if you don't know how to do this. But if you had a quadratic equation such as x squared plus 5x plus 6 equals 0, you might remember that you could solve that. If somebody asked you to solve that, you could figure out what x is equal to. The way to do that would be first to factor this trinomial that you've been given. 3 terms as a trinomial. And this would factor as x plus 2 times the quantity x plus 3 equals 0, because the two numbers that multiply to make 6 and add to make 5 are 2 and 3. Then you would have set each one of these two factors, so these are two things multiplying, two factors equal to 0. Okay, then you would have solved each one of these. So to solve, to get the letter alone, when it's linear like this, if there's no exponent, all you have to do is do the opposite of what's happening. You got to do the inverse. So right now I have x plus 2, so I'll do the opposite of adding 2, which is subtracting 2. If I subtracted 2 from both sides of this equation, I would get x is equal to negative 2. And if I subtracted 3 from both sides of this equation, I would get x is equal to negative 3. And so this is how I would start with the equation and get to the solutions. Now this, I'm starting with the solutions and they want me to move backwards to the equation. So we're going to do this process, only we're going to do it backwards. So let's start with the two answers they gave us. We're actually finally solving the problem. The two answers they gave us. One, they gave me an answer of x is equal to negative 3. A root of negative 3 means that's one of my solutions for x. And they gave me an answer of negative 1, a root of negative 1. So that must be true that either x was negative 3 or x was negative 1. And it looks a lot like this last step here. Now I'm going to move up. I'm going to take each one of these answers and set them equal to 0. So if I want this to be equal to 0, I'm going to have to do the opposite of negative 3 or minusing 3, which is adding 3. And so I'm going to end up with x plus 3 is equal to 0 over here. And same thing over here. I'd have to add 1 to both sides. So I'd end up with x plus 1 is equal to 0. Okay. Now you can see if you look at the step before this, these two things, before they were separate, they were together. They were multiplying. And so that's what I'm going to do. I'm going to take these two separate equations and have them multiply with each other. So it must be true then that if one of these is equal to 0, then it must be true that if I multiplied the two together, x plus 3 and x plus 1, I would still have 0. Now I'm almost done, but I need to get from the factored form out into the original quadratic equation form, the standard form of it. And to do that, I'm just going to do the multiplication implied by these parentheses. These two things are multiplying together, so let's multiply them out. Now, that's why I said you needed to remember how to multiply binomials. These are two binomials. And so a lot of you guys remember the way to multiply binomials is with what your math teacher often called FOIL. But the idea here is that every term in this first binomial must multiply with every term in this second expression over here. Okay, so I'm going to go ahead and do that multiplication. So here, first term times first term, x times x, would give me x squared. Okay, now let's do the next one. We're going to take the same term x, but it also has to multiply with the 1 over here. So x times 1 is 1x, or if you're a mathematician, which we are, you're way too lazy to say 1x. And so let's just undo what I did there. I don't like that. My ugly plus sign. Let me use this. But as we say as mathematicians, I just got all lost. What was I talking about, y'all? Let me back it up. Oh, x times 1 is 1x, or just x. We wouldn't bother to call 1x 1x when we know we could be just lazy and just call it x. Okay, so we got that. Now let's do the next term. 3 times x. If we finished up passing out this x, we passed out to everybody over here. Now it's time to pass out the positive 3. So positive 3 times x would give me plus 3x. And final term, if I'm doing this positive 3 times the last term, the 1, 3 times 1 is just 3. And so I would get plus 3. And the whole thing is still equal to 0. So there we can see this thing is multiplied out now. Only one last thing to do to simplify it, and that's to combine any like terms. We should know that any x terms, whether it's just 1x or 3x, can combine. So let's go ahead and do that. I'll still have my x squared term. There's nothing for it to combine with, so it won't change, but x plus 3x would give me 4x. X plus 3x would give me 4x. And I'll still have my constant term because there's no other plain old numbers for it to combine with. So I now have x squared plus 4x plus 3, and the whole thing is equal to 0. Okay, so we got to this form here, x squared plus 4x plus 3 equals 0. And most students right there would just be like, I'm done. In fact, I tried to do that 3 times already. But the deal here is that we haven't dealt with this last piece of information yet. We dealt with the roots, but we haven't dealt with the leading coefficient of 2. The idea here is that you'll get the same answers from a quadratic equation regardless of what it's being multiplied by. I should say, let me say that again. Let me phrase that a different way. You have lots of different quadratics that'll give you the same answer, but they're all going to be multiples of each other. Now, hopefully that makes sense. They're all multiples of each other. And that's because, I can divide two sides of an equation by any number, and if one of them is 0, it's always going to stay 0 over here. So this idea here is I don't yet have a leading coefficient on this number. See how it's only an x squared? I need to have a leading coefficient of this number. So I have one more step that I need to do to this equation. I need to take this entire left-hand side, and in order for it to have a leading coefficient of 2, I need to multiply it by 2. Now you might be thinking, Kate, is that legal? It's totally legal. We've always been allowed to multiply, do anything we want really to an equation, as long as we do it to both sides. So I'm going to take this parentheses here, and I'm going to put a parentheses here. What I want to do is, in order to make my leading coefficient 2, I want to take this entire equation and multiply it by 2. It's the only legal way to do that, if you do it to the entire left-hand side. And now the rule of math is we can do whatever we want as long as we do it to both sides. That's the rule of algebra, I should say. I can do whatever I want to an equation as long as I do it to both sides. So what I'm going to do now is I'm going to take the entire right-hand side and also multiply by 2. So great, multiplying both sides of the equation by 2 in order to get that leading coefficient that I want, and it's legal again because I did it to both sides. So over here, I'm just going to get 2x, right? You just pass out this multiplication. 2 times x squared is 2x squared. So I'll get 2x squared plus, well, 2 times 4x, again, I'm just passing this out, would give me 8x. And then 2 times positive 3 would give me positive 6. And that whole thing is equal to this side. But 0 times 2 is just 0. Okay, great. And now I have one who had the right roots, but it also has the right leading coefficient. And so my correct answer is not the last one, which I tried to choose quite a few times, but really this one, 2x squared plus x squared plus 6. But I still will make the point that whoever's math teacher this is made a mistake. This answer, the only reason they made a mistake is because this says what is the quadratic equation whose roots are all this. This is not a quadratic equation because it's not an equation. Equations have two expressions set off by each other with an equal sign. So for this really to be a quadratic equation, it would need to say 2x squared plus x squared 8x plus 6 is equal to 0. Now it's an equation. Now it's really right. So that's super satisfying. Y'all, whoever math teacher wrote this, you can go back to your math class and say, I think you might have had an error in your answers, miss. Your answers were not equations, and this asked for an equation. And then you could sound smarter than your math teacher, which is always satisfying. So hopefully this video makes sense. I hope that you got a lot out of it. Remember that you can ask me any math question you want. I'll do my best to answer it. Drop it on my YouTube channel, drop it on my Light and Salt Learning Facebook page, and I will try to make a video for you.